Hi students, welcome to BGR Tech Talks. My name is Srikanth and I'm a student of BGR Government Degree College. Today we're going to discuss one of the important topics of operating system called CPU scheduling. So let us say there are many processes which are in the ready state to be executed by CPU. So which process has a chance to own the CPU for execution while another processes are in the waiting state is determined by CPU scheduling. So simply CPU scheduling is a process of determining which process will own CPU for execution. The main criteria of CPU scheduling is to maximize the CPU utilization and minimize the waiting time of a process. So basically there are 5 most important CPU scheduling algorithms which we're going to discuss, and they are first come first serve scheduling, shortest job first scheduling, shortest remaining time scheduling, priority based scheduling, and round robin scheduling. So all the above algorithms are either non-preemptive or preemptive. Non-preemptive algorithms are designed so that once if a process entered the running states, it can't be stopped until its execution. Whereas the preemptive scheduling is based on the priority, where a scheduler may stop the lower priority running process anytime when the higher priority process enters into the ready state. Let's understand this non-preemptive and preemptive with a very simple example. Let us say we have two processes called process 1 and process 2. In this, the process 1 is in running state. Even the process 2 is much more important to be executed than process 1. It should wait until the completion of process 1. While coming to preemptive approach, the scheduler stop the lower priority process P1 and give a chance to higher priority process P2. Let us discuss some basic terminology before going to the different algorithms of CPU scheduling. The first one is burst time. The time process required for running on CPU is called as burst time. The next one is waiting time. The time spent by a process in ready state waiting for CPU is called as waiting time. Arrival time. The time at which the process enters ready state is called as arrival time. Exit time. The time at which the process completes execution and exits from system is called as exit time. Turnaround time. The total time spent by a process in system is called as turnaround time. It is also defined as the difference between exit time and arrival time, or the sum of burst time and waiting time. Now we're going to discuss FCFS algorithm. FCFS means first come first serve. FCFS algorithm is a non-preemptive algorithm. According to FCFS scheduling, CPU will be assigned to the process which arrives first. So for example, let us say I have two processes called P1 and P2. P1 arrives at 3 units of time and P2 arrives at 6 units of time. So P1 arrives first, P1 will get a chance to work with CPU. P2 should wait until the completion of P1. And the base idea is the process which arrives first will get a chance to work with CPU. So if you can observe the table, there are 3 processes P0, P1 and P2. P0 arrives at 0 and the burst time, that is the execution time, is 13. P1 arrives at 1 and the execution time is 7. P2 arrives at 2 and the execution time is 2. As you can observe the Gantt chart, P0 started working with CPU at 0 and exited at 13. P1 started working with CPU at 13 and ended at 20. P2 started working with CPU at 20 and exited at 22. The waiting time of a process is difference between exit time of previous process and arrival time. If we calculate the waiting time of 3 processes, the waiting time of first process is 0 and waiting time of second process is 12 and waiting time of third process is 18. And the average waiting time is 0 plus 12 plus 18 by 3, that is 30 by 3, that is 10 units. The major drawback of first come first serve scheduling is convoy effect, which means smaller processes have to wait for a long time for bigger process to release CPU. As you can see in the above example, the execution time of process 2 is only 2 units, but it should wait for 18 units to work with CPU. We'll cover the remaining algorithms in next video. Thanks for watching.